Okay. Good morning. No, good noon. Good noon, internet. Oh, it's a nice tea there. Today I've been having some real issues with my internet connection. Um, yeah, apparently there's been Rogers issues in the area. So, yeah, I'm gonna see what I can accomplish today. I do have a bit on the tray to get to. Not a ton today, maybe not as much as some other days. Uh, you just grab my pins here. It appears that I am dropping frames already. It appears that I am dropping frames already. Yes, indeed. Here we go again with the email. Every week I hope that it's from a female. Oh man, it's not from a female. No, it's from bed. You try a dragon. I want to see your skills of an artist. Well, GTG. Guys are from California. I mean, the strong bad impression wasn't great, but my attention to detail, I got at least like 95% of those words right. That's pretty good. That's, that's how much time I spent watching Homestar Runner. hmm Oh, it's good. It's the finest. It's the finest internet cartoon there's ever been. It's like the Bugs Bunny and Tweety show of the internet. It really is. It's like Looney Tunes. It's like Looney Tunes for the digital age. That's a bit grandiose. It's Looney Tunes for internet nerds between the ages of like 36 to 30. I don't know. Early 30s internet nerds, Looney Tunes. There we go. Now, that's on point. It's great. Anyway, oh, cute doggies. Yes, thank you. Those are Flurry and Smokey. And that is in Hampton. But judging by your name, hmm. Yeah, those are adorable little guys. Get my cursor over here. Here we go. There is Smokey, and there's Flurry, and Smokey, and Flurry. Yep. Yeah, we talked about those guys before. He is a see Belgian Tervuren and Irish Setter and a whole bunch of stuff, all mixed up in a bucket, and he's very fuzzy and soft. And then this Flurry, she's a good girlie. She is a Labrador and a Husky. Yes, has like two layers of fur, right? So she's got like the outer coat that's very water repellent, and then the undercoat, which is very warm and soft. Anyway, let's take a look at what we're going to be covering today. So first up, I've got several students who are working on Math 1101C right now. So I'm going to do a fair bit of 1101C stuff today. Um, let's see. I'm going to do some stuff I'm going to do the computer activity. Yes, I'm going to do the computer activity of Math 1101C. I'll do part of the Unit 1. There is no Unit 1 review, unfortunately, for 1101C, but I will get to that one. I will get to some stuff in the course rather than doing the review sheet, I mean. And then I'm going to do some overall review for Math 1101C. Then I'm going to do, let's see what else we got here. Some trimmed mean. Trimmed mean is a really good topic that Esther is going to be doing very shortly. So hopefully the video stays up now that I've reduced my kbps even more severely. No, we are dropping them frames again. Look at that. Okay. Yeah, yeah. Even at 800 kbps, we are dropping some frames here, folks. I'm gonna stay the course, steady the hand at the tiller right now. Keep her keep her steady at 800, my son, and we'll see how that works out. Let me refresh around that. Let's see, systems of equations, unit two. Yeah, so I'm going to start off with this one. I think this is a good place to begin. This is the Math 1101C Systems of Equations Computer Activity, right? So this is a good one for us to start off with because it's actually not even going to be on paper mostly. So I'm going to uh, switch this guy back over to here so we can see that a little bit better. So in the computer activity for 1101C, what we're going to be doing is using Desmos.com, right? So Desmos.com is a very useful internet calculator that you can use. It does everything that the TI-8084 for 83 can do. It can do just as well. Let me just grab out my pal here. Got him shoved away in a bag for a second, but this guy, yeah, that little guy, if you haven't got that little guy, I wouldn't worry about that little guy because you can use this guy instead. You switch on over here. Here we go. Yeah. So in Chrome, we can do basically whatever we could do on the graphing calculator. This one, right? By using Desmos.com, which is what we see here, and that's what this activity is discussing. Okay, maybe I'll go lower. See how low can you go? Bit right? How low indeed can you go? But we'll get there. We'll get to a point where I'm not losing 10% of my video to just some little Rogers elves that are scampering around the wires. Okay. Looks like my video has recovered somewhat. Oh, don't need to see my email over there, do you? No, you don't. Definitely don't need to see that. Okay. Right. The computer activity. So I kind of need to have a document display here, don't I? Yeah, there we go. So we're going to go to Desmos and graph each of the following systems of equations on the computer and sketch them on the grids provided. So first up, we're going to graph them on the computer, and second, we're going to sketch them on the grids provided, right? So if we skip down below here, we see that the first question, so this is math 1101C computer activity, right? And so this is question one. Question one then is solve the following by graphing. And it's x plus 2y equals -2. And it's x minus 4y equals 16. Okay, so we're going to go ahead and solve these ones by graphing. So let's just go back over to Desmos. Right, so we're going to switch over here. And let's just type those ones in just like they're written. So x plus 2y equals -2. There we go. See, all you've got to do, you just go type that in just like it is, and it comes up. It even automatically, you see over here, this little bit, it automatically detects that it's a line once you finish typing it in, right? Because it recognizes what the form of a line is. Okay, so now I'm going to go ahead and I'm going to create another one. So over here, what I'm going to do now, I clicked this add item button, this plus sign, right? And then down from here, I'm going to pick expression. So now I have another opportunity to add another one of these ones. All right, so now I'm going to do x minus 4y equals 16. For the x, I'm just using the normal x, right? Just a normal button on the calculator, on the keyboard. Unlike the calculator, right? Because on the calculator, you have to use a specific one. So there we go. X minus 4y equals 16. Now we just need to go ahead and graph those guys. Well, from the graph, we can now see that the point of intersection is going to be 4, -3. Right? And if it, yeah, it doesn't mention for you to do anything other than to graph it, right? Graph it and then solve it. So solve the following by graphing. Yeah, there we go. So that is exactly what we just did. We solved the following by graphing. Right? So let me see. Okay. Looks like the video is holding steady for now. Yeah, drop a message in chat if you if you're noticing any issues with it, but I think we're doing okay here today. So solve the following by graphing. Let's go down to the, oh my goodness, this one. Here we go. So now we've got three other examples here. I'm not going to go through every single one of these ones on here, but this was just to show you how, basically just how Desmos works, right? You can go on and you just type those ones in, and then you can get the answers. You just have to make sure that when you're typing them into Desmos, oh, oh, I'm back over, back over again. Um, yeah, make sure that you're adding an expression here. The other ones are not going to do what you need them to do for the line. But yeah, you just sort of point the camera to the camera. Maybe you can point the camera to it too. Point the browser to Desmos and way to go. So back over to my document display. I'm going to carry on now, and I'm going to show some of these ones sort of by graphing it by hand. Right? Now there's a whole load of different ways to graph these ones by hand. I'll show you basically what's my preferred one. So now that was computer activity over there, but now this is going to be, I think this was worksheet 1. Yeah, I'll do this in blue now. So this is now worksheet 1. Worksheet number 1 there. So I'm going to go ahead now and graph, let's see. Yeah, I'll do number 4. Worksheet 1, number 4. So what we have here is 2x minus 3y equals -6. Down below we have 4x minus 6y equals 18. Okay? So how can we graph these ones? Well, like I've mentioned before, I'm a big fan of taking this and turning it into just slope-intercept form. I find that to be the most intuitive. So what that means is I'm going to get the x and the y's on different sides, and I'm going to make sure that the constant is on the same side as the x, right? So if I take this one and move it over here, I'm now going to call this 2x plus 6 equals 3y, right? Because now what I've done is I've taken this and moved it to, taken this one rather, and moved it to the other side of the question, taken this 6 and moved it to the other side of the equation as well. Right, so now I'm just going to divide by 3 because I want to have y over here by itself. We're going to have 2 over 3x plus 2 is equal to y. Okay, so let me go ahead and draw out a coordinate grid so we can see this one here. I haven't gotten a screenwriter yet. If anyone has a suggestion for a good screenwriter program, I am all ears for that. Definitely could use one of them. Those are y's and those are x's. Okay, so again, right, this is just sort of a rough graphing of this one because I don't have the graph paper here. But now I'm going to do, let's see, 2 or 3x plus 2. So we know that the y-intercept is 2. I'll just drop 2 there. And let's see, I'll do the line in blue because I was writing the working in blue. So here's my first point. And the next one is going to be 2 over 3. So a rise of 2 over a run of 3. So the run is 3. 1, 2, 3. And the rise is, no, it's rise over. Yeah. So the rise is 2. 1, 2, right there. There we go. That is about where the point will be. Now this is freehand, of course, so the line is not going to be 100% accurate, although your lines are never 100% accurate, of course. So there we go. That is the first one. The next one now I'm going to do in green, just so we can see it. I checked in yesterday, I had to run out, so yesterday I didn't get any work done. That's okay, Brittany. Like, sometimes these things happen. Really grateful for you to still be checking in. Yeah, remember to check in by email in the morning, which I believe you did today, which is great. Thank you very much. Yeah, I'm still going to be here just doing some stuff for people that I get submitted. If you are working on anything right now, just let me know in chat, and I can answer some questions on that as well. Right? It seems like my internet is stable enough now that I've reduced the bit rate down. Hopefully the quality of the stream is still good. Yeah, looks fine. Might not be great for playing high octane video games, but it's super great for high octane mathematics. I do have Skype, yes, but yeah, you can email me to arrange for different sort of um, types of communication. So here then, 4x minus 6y equals 18. Again, I'm going to try to get the x's and the y's to be on separate sides, so I'm going to move those y's over. So that'll now then be 4x equals 18 plus 6y. I'm just going to do this one at a time. I'll move the 18 over, so it's going to be 4x minus 18 equals 6y. And then divide both sides by 6. So it's going to be 2 over 3x minus 3 equals y. Okay? So now I'm going to go ahead and then 2 over 3 minus 3, so we're going to go down 1, down 2, and down 3, like so. Then I'm going to put my first point there. Boy, my kbps just dipped to 0 briefly. Wonderful. So then 2 over 3, a rise of 2 and a run of 3 is going to get my next point to be right here. So I'm going to go ahead and I'm going to join those ones up like so. Let me get that joined up there. Yeah, look at that. Now, ha! I wondered why was I getting so many extra shadows? Yes, my beautiful lighting. There we go. There we go. I knew there was something amiss. Knew there was something amiss with my lighting. I shouldn't be having those kind of shadows below my hand. I fixed that. There we go. Yeah, look at that. Look by comparison, right? See how much less shadow I have there now? Yeah, it's good stuff, right? It's basic, some good set lighting. It's good. Anyway, we will see here that these lines aren't going to cross, right? I mean, maybe I didn't draw them perfectly parallel because I'm not using a actual piece of graph paper, but we can see that this one has a slope of 2 over 3 because this is now slope-intercept form. This one has a slope of 2 over 3. So if they have the same slope, then they're either parallel lines or the same line. And we see that they're not the same. Is it that? And that one. Need to talk to me over the phone about a question? Yes, yes. Please refer to the first email that we sent out before distance teaching began if you want to know the sort of the procedure for that. But you can contact me anytime in the morning before I start or after the stream is over, right? Okay, so that then is how we're going to do it for worksheet number 1. As we see there, right? These two guys now are parallel. So let's see, are there any other ones that I'm going to do here? Yeah, I'll do number 6 as well. Okay, Brittany, are those is that pages in Prism Math Purple that you're talking about? Okay, so for number 6 here, right, just figuring out what I'm going to be doing next. So I will do, Brittany, I will do those Prism Math Purple questions, 242, 11, and 12. I'll do that next after I finish another question or two on this activity here. Right, so this is Unit 1 of Math 1101C. Then I'll do, Brittany, I'll do your questions, and I'll go back to 1101C afterwards. Then after that, I have some trimmed mean questions, which I think will be very beneficial to Esther if she's around. And if she's not, she can always watch it afterwards, provided that Rogers lets me make it that far. It dropped a lot so far. Okay. Question 6. That is 3x plus y equals minus 2, and it's y plus 5 equals 0. Now, the reason I want to do this question specifically is because it's got one little thing that's a bit different, might seem a little, maybe a tiny bit confusing, but it's really not that big a deal, right? So if I was to take this one here, say I was to take this one and do it first, where's the x in here? Well, there is no x, right? There's no x at all. What do I do? Well, we still get y by itself. Oh, sorry. We don't do that. We absolutely don't. We do this. Y equals negative 5, right? Because this 5 that's there by the y moves over. Say if, as an aside, say if we had, say, x minus 4 equals 0, that would be x equals 4, right? Now, to show you the difference, I want to take this opportunity. Now, this one is an aside, as the circle usually, as the bubble usually denotates, right? So here, first up, we have y equals minus 5. So where is y equals minus 5? How do we draw that line? Well, that's just y, the y-axis, equals minus 5. It's all the points where the y-coordinate is minus 5. So it's 0, 5, it's 1, 5, 1 minus 5, it's 2 minus 5, it's negative 1 minus 5, it's all of them. So we go 1, 2, 3, 4, 5 here like this. And then I'm just going to draw a horizontal line. Like that. Right? And there's your line. If, for example, and you will see this sometimes in these courses, like very rarely, but sometimes, if you see x equals something, what that means is what you're going to do is take all of the points where the x coordinate is 4, right? So the x coordinate is 4 is 1, 2, 3, 4 over here, right? So all the points where the x coordinate is 4, well, it's 4, 0, it's 4, 1, it's 4, 2, it's 4 minus 5, 4 minus 12. You know, it's all those. So this one's actually a vertical line. Right, which is this. It's worth knowing. Now, this is not part of the question to draw the aside one over here, but this one is not a function because it fails the VLT, or the vertical line test. Right? So this one, you generally wouldn't see in a calculator. The TI-84, the way it works, it actually can't even graph this one, right? Because if you look over here at this guy, you see they're all y equals. You can't even put in an x equals. Right? But a vertical line, like so, we can graph them by hand, of course, and I believe you can graph them on Desmos and stuff like that as well. But for an activity like this, you know, it's worth knowing that it's the only time where you're going to see an actual vertical line is if you have an x equals. Excuse me. So now I'm going to go ahead and solve this guy here as well, this one. So again, right, now we're back to more of the normal. We want to get the y by itself and then move all the x's to the other side. So we'll just have y equals negative 3x minus 2. Easy enough. It was just one step of rewriting and we're there. So minus 2 is our intercept, and the slope is negative 3, which means when it goes to the right 1, it goes down 1, 2, 3. Right 1, down 1, 2, 3. So again, yeah, where this is freehand, it's getting a little sloppy. But that is where that line would be. There you go. Okay, and if you were told to graph it like this, then the intersection that you're going to be looking for, you can get off the graph. Right? Okay. But the intersection is going to be 1, -5. Right? So we can see from here now that our POI is 1, -5. And that is what we would write down as the solution. Right? So when if you're told to solve them by graphing, you can just solve them by plugging them in like that. Okay? Okay. That was those ones. Brittany, yes, you wanted, what was that? Page 242. What is page 242? I wonder. Let's find out. Yes, sorry if the stream is buffering or anything like that. There's not a ton I can do about that, I'm afraid. It's quite unfortunate. Page 242. Okay. Okay, I see what you're doing. All right. These are all right questions. Yeah, let's go over a few of these. So, I will just name the operation that should be done first, then find the value, right? Is the first thing that we're doing. Let me switch this back over to my working display, and let me switch this back over. Oh, let me switch this back over to my adorable display. Here we go. Yeah. Okay. Then name the operation that should be done first. Then find the value. Okay. Let me see. I'm zoomed in decently here. Understand the first three? Okay, sure. Great. Yeah. So here we're just picking what the first operation is going to be. The true and false ones, yeah. I saw that that's what you were asking about, but I am going to do a little bit of an intro to what the other ones are here, right? Because if you understand the rest of them, these last ones should be fairly straightforward. But let me go ahead and tell you what, I will write them out so that I can see them, and then I'll show you what it does in the book for those then. So number 11, right? And this is Prism Math Purple, page 242. 242. Okay, so number 11 tells us, writes down 8 plus 24 divided by 4, and it uses the division sign, minus 2 equals 12. And it's asking, is that true or false? All right, well, how are you going to tell if it's true or false? Well, all you got to do is, instead of putting 12 there, just put x there, and then solve it and see. Solve it and see if 12 is indeed what you get. So that's what I'm going to do. I'm going to or you can just work down through this side like it was an expression, and we see what we get, right? So we've got 8 plus 24 divided by 4 minus 2 equals 12. The important part of this sort of activity is bed mass. Actually, let me move the book out from under me so I go back to a nice flat surface. So what we had to deal with here is going to be bed mass, is the root of what we're doing. So what do these stand for? Well, it stands for brackets, exponents, division, so on. Multiply, add, subtract. Right? I'm not going to go fill out all of those guys. Right? It's worth knowing, in some places, it's called bid mass instead, where I stands for indices. It's the same sort of thing, bid mass and bed mass, but for whatever reason, North America, it's called bed mass. UK, they call it bid mass. I mean, indices are just another way of referring to it, right? But anyway. So once we go down through here, we have to compare what we've got to solve with this order of operations. So do we have any brackets? No, no brackets. Okay, we can move on. Do we have any exponents? Remember, exponents are the numbers in the corners. Do we have any of those? No, we don't. Next one. Division. Now, it is important also to know that in BEDMAS, there are sort of two sets, right? D and M go together because they are actually the same operation. Same with A and S. Addition, subtraction, multiplication, and division are kind of two different sets, right? So those two ones work together. Do we have any division? Well, yes, we do. We have the division of 24 divided by 12. So that's the first thing we've got to do. So I'm going to write down the whole expression again now, just with this middle part solved. So it's going to be 24 over 4 is going to be 6. So it's 8 plus 6 minus 2. And I'm going to leave out the equals 12. We're going to find out if it does equal 12 because I'm just going to keep going down. 8 plus 6, because now we have addition and subtraction, which are just done in the order that they're written. So it's going to be 14 minus 2, and that's going to be 12. So that one checks out. Checkerino. It's done. 11a is true. Okay, let's try 12. That's 24. Let's see, 24 minus 10 minus 3 times 4 equals 2. Does it? Well, we had to check our BEDMAS first. Brackets, no brackets. Exponents, no exponents. Multiply and 52 is 2a. Multiply and 52. Not quite. And you're almost there. It's not 52, right? Because 9 times 6 is 54. 54 minus 3 is going to be 51, right? But yes, you're very close. That was just the it was just a addition thing, right? So here, then we have 24 minus 10 minus 3 times 4 equals 2. So we know that the first one that we're going to do there is going to be multiply, right? So once we multiply negative 3 times 4, that's going to be a negative 12. So we're going to have 24 minus 10 minus 12. 24 minus 10 is 14. 14 minus 12 is 2. So this one is true. This one back up here was also true. Okay, so 11a and 12a are both true. Okay, and it is important to know here, for example, that this would be a negative 12, right? Because it's a negative 3 times a positive 4. And then afterwards, you just do these in order. Okay? Tell you what. Yeah, maybe there was a bit, maybe there's another one here that I can do to show you another example. Yeah, I'll do 11b as well. I know I'm ending up doing most of these, but there's only 4 on the page, and it's important for these ones that you less that you understand the whole true and false thing, but more that you understand just the way that the BEDMAS breaks down, right? So 18 divided by 3 plus 5 minus 2 in bracket equals 3. Now here, this one, the bracket actually doesn't do anything, really, because there's a plus outside it, and it's just 2 minuses in there, right? This is an example of one of the properties that you did earlier in the course, called the associative, right? Where the sort of if these two associate together with brackets, it doesn't actually do anything, right? Because brackets here or not here, it's still going to end up being 5 minus 2 because this one is away from it, separated by this plus. Right? If this was a multiply here or a divide here, then it would matter a whole lot. Okay, Brittany, you really shouldn't type your phone number in chat. I'll tell you what, Brittany, you need to email me if you want me to use any other form of communication, right? Like the stream. I'm glad that you that you log on and you use it. That's really great. But we do kind of need to make sure I don't know, that you're contacting me through other means and not just through the stream, right? So if you want me to call you or something like that, it's totally fine. If you want me to Skype or anything like that, but do please send me an email about that. Okay? No. There's no worries. No worries. Just yeah, contact me with the email. Thanks. Okay, so for B then, I'm going to go ahead and just do the division here first. 18 divided by 3 is 6, right? And that's going to be plus 5 minus 2. Um, but these ones, well, actually, no, sorry. I should make a good example. I should, boy, I should show a good example here. So it's 18 divided by 3 plus 3, right? Because here now, we had to do the bracket first. I was just rambling on saying how it didn't matter, but we do still have to do the bracket first. 18 divided by 3 is 6, so it's 6 plus 3, so that's 9, right? So this one is actually false. Okay? All right, good. All right, good stuff. So that was Prism Math Purple, page 242. That's enough on that one. So I'm going to next go back to Math 1101C. If you're here to listen to Math 1101C stuff, I'm going to bring that one back up again. But now I'm going to go on to a different part of Math 1101C. So, Adam, if you found a way to watch the stream, then this one will be quite useful for you. But, excuse me. Betty Ann is also, I believe, on this course right now, so this will also be very useful for her. So what is let's see, I'm going to start off with this one here, question 5. It's a slope-intercept form, the line y plus 4. Okay, instead of reading it out, I'm going to write it out. So this is Math 1101C. 1101C, and this is, let's see, yeah, just question number 5. Oh, you're very welcome, Brittany. If you have a question about that, you can try to type it out if you want, and I can get to it right now. Or once the stream is over, you can, yeah, I'll see the email that you send, and then we can arrange something else. Okay. So the line is y plus 4 equals negative 2 over 3 x plus 5. Right? So what's the slope-intercept form of the line? Well, the slope-intercept form is my good old buddy y equals mx plus b. Easiest form of the line there ever could be. But how are we going to get this one into that form? Well, first we're going to have to multiply out what's over here, right? Because we can't have the bracket sort of staying there. So what we are going to have, this one is going to become y plus 4 on this side, and over here we're going to have negative 2 over 3 times x minus 10 over 3. And the reason we have minus 10 over 3 is because this is negative 2 over 3 multiplied by positive 5. Right? Now I just had to move this 4 over, so that's going to become a negative. So it's going to be y equals negative 2 over 3x minus 10 over 3 minus another what? Well, 4 is going to be 12 over 3, right? So it's going to be y equals negative 2 over 3 x minus 22 over 3. There we go. All right, so the answer here is D. Question D. Or answer D. Okay. Number 5. Number 10. Let's see, I'll do that one in blue. So let's scroll on down here now to number 10. What is the slope-intercept form of the equation with an x-intercept of 4 and a y-intercept of minus 7? Okay. Yeah, there we go. That's a bit better. You can see that a little bit better. What's the slope-intercept form of an equation with an x-intercept of 4 and a y-intercept of negative 7? One reason I really wanted to answer this question is because this is a great example of my when in doubt, draw it out philosophy. Right? It is definitely a philosophy. It's a sort of a life philosophy, right? If you're at a store and you can't figure out which type of bacon you want to buy, just try drawing them. Whichever one you can get a nicer picture of. All right, but in math here, when in doubt, draw it out. I mean, with regard to graphs, right? We're told that the slope-intercept form, we're looking for slope-intercept form, so we're looking for this guy again, but it has an x-intercept of 4 and a y-intercept of negative 7. Well, 1, 2, 3, 4. X-intercept of 4 is right there. 1, 2, 3, 4, 5, 6, 7. Down here. So this is 4, comma 0. This is 0, comma negative 7. And then we're going to draw our line like this. Right? No, maybe I'm a little bit off. A little bit off there. There we go. Don't mind me. Okay. So from this now, we can see it quite easily. But we could have gotten a lot of the details from this just straight from the question as well. Right? But I'm saying that if you get to a test and you're like, I'm not sure what to do, take the 30 seconds or whatever and sketch it. Right? Especially if you're just doing it for your own workings. You can do it like this or whatever, just to quickly see. And from this now I can see, oh, right, yeah, the intercept is obviously negative 7. The slope is obviously 4 over 7 because it's right here, right? It goes from here to here, so it goes up 7 and to the right 4, right? And we can obviously see that. We can see it from the question too, right? But you notice from the question, they're trying to be tricky. And in a testing scenario, you might be sitting there and think, well, wait a minute, if the intercept is negative 7, does that mean that the slope is negative? Well, x-intercept is 4, you have the y-intercept is negative 7, so should it be negative 4 over 7? Maybe it should, right? If you're not sure, just draw it out. The answer is going to be C, which is y equals 4 over 7, x minus 7. There we go. Good stuff. Next one is question 12. How many solutions exist for the system that? Right, well, how can we determine that? Well, the one way we can determine that one, question 11, over here, let's graph them out. Let's try to solve it, right? Because there are basically 3 different scenarios, right? There's either going to be 0, 1, or infinite. Because we know that these are both straight lines, right? So right from the start, we can get rid of C. Because if the lines don't curve, there can never be 2 intercepts, right? So here now, what I can do is I can solve them by substitution. That's going to be elimination. I'm going to solve it by elimination. So we have 2x minus 3y equals 12. Down here we have, I'm going to switch them around because see they pulled a sneaky on you. They switched the order of them. I'm going to swap them around and call it negative 4x plus 6y equals 24, like so. Right? So now what I'm going to do is I'm going to double the top one here. So that one's going to become 4x minus 6y equals 24. Huh. So it's looking a little bit suspicious, isn't it? Well, what's going to happen now? So I'm going to take these ones. I want them to cancel out. I'm going to add these ones together, right? Because let's see, I've doubled this one, I've doubled that one. So I'm going to get 0 equals 48. That doesn't make any sense, does it? How in the world does 0 equal 48? I'll tell you in what world 0 equals 48. No world. It never does. 0 does most certainly not equal 48. So you know what that tells us? That tells me that there's no solutions. The answer is A, no solutions. But let's take another quick look at that guy. Let's see if something else agrees with me that there are indeed no solutions. So let's pop on over to Desmos over here. Now let's check it out. See what these lines actually look like. So I'm going to close down those two guys. Then over here I'm going to type 2x minus 3y equals 12. Okay, I'm going to do another one now, and I'm going to do negative 4x plus 6y equals 24. Hey, look at that. So what does that tell us? Look at those lines, right? See? Oh, that was the wrong position of Desmos to grab there, Peter. That was the wrong one. That was the OBS one. I needed to grab the Chrome one. There we go. Yeah, I'll figure it out eventually. One of these days. Okay, so there we go. We can just keep on scrolling, keep on scrolling, keep on scrolling. Zoom out as much as we want. Well, if you zoom out enough, they'll start looking like the same line. Hey, look, now they cross. Well, they don't. They don't actually. I've just zoomed out so far that Desmos is blurring them together into the same line. But my point is, these are parallel lines. They never cross. So if you're going to use something like systems of equations, like what I've done here, to solve those, it's totally fine to do. It's a good idea. But you got to be prepared for when there's going to be a weird result that you didn't expect, like in the slightest. All right, so now we're back on over. Oh, good, here we are. Yes. Okay, question 11. Question 11 then is going to be A. That was my point. See. Oh, I didn't even need to do question 11, did I? I needed to do question 12. Question 12. So, what is the solution to the system on the grid? Well, that's going to be negative 5, positive 3. Negative 5, positive 3. A. Right? Easy stuff. That must have been question 11 I was supposed to do. Question 11 is an interesting question. Yeah. Question 11 was a good one. Hope you liked that one, chat. I know I did. That was a good time. Now I'm going to go on to question 26. Question 26. Okay, solve the system of equations by substitution. Oh, good. Okay, excellent. Substitution and elimination. Yeah, I'm going to do all of 26, and I'm going to do 26 and 27 rather. So these two on the board. On the board. On the board. Oh, how adorable. He's acting like he's in school. So this is Math 1101C. 1101C. And this is question number 26. Okay, so solve the system of equations by substitution. That's going to be 3x plus 2y equals negative 3. And then 6x minus y. 6x minus y equals 4, like so. Okay, how am I doing now with the, no. I jinxed it. I jinxed it. Twitch chat, I jinxed it. I leaned over to look at my KBPS and it dropped to 0. I guess it's like, okay, my current KBPS for my stream, I guess, is kind of like You know, it's like quantum mechanics, whereas like if you understand the position, you can't tell the velocity. Well, if I see the bandwidth, it becomes zero. It just sort of hides. It's like, oh, we can't let him see. Can't let him see bandwidth in the green. We got to duck. We got to get some red up there. Just slap that red on there. Get some more drop frames. It's good. It's good stuff. Boy. Anyway, I need a sip of my tea. All right, we're still keeping it. We're still keeping with the Earl Grey. We're not extinct yet. I've got like I think two tea bags of Earl Grey left. Boy, oh boy. Anyway, the drift in a sea of no bandwidth. It's very appropriate. So yeah, we're doing these ones by substitution. So by substitution means we're going to get one of the variables to be by itself. So I'm going to get y here to be by itself because we're almost at that point anyway. So I'm going to go ahead and solve this guy with 6x minus 4 equals y. Because I just move the y across, move the 4 across, boom, boom, done. Right? Easy. So next up now, I'm going to substitute this back into the other equation. Now again, I will say that it's essential to substitute it into the other one. Because if you substitute it into the same one, you're going to get your 0 equals 0. So 3x plus 2 outside of 6x minus 4 is going to equal negative 3, like that. Right? Now I'm just going to go through and solve. 3x plus 12x minus 8 is equal to negative 3. 15x is equal to positive 5. X is equal to 1 over 3. So there we go. Right? So now I've got a value for x. Easy enough to get a value for y now. Now I'm going to go back and put it into here. I'm going to have 6 times 1 over 3 minus 4 is equal to y. 6 times 1 over 3 is 2. So 2 minus 4 is equal to y. So, excuse me, negative 2 is equal to y. Just like that. Okay, so now we know that for question 26, the point of intersection is going to be 1 over 3 negative 2, like so. All right, great. So now for question 27. Here we go. So now solve the system of equations by elimination. So elimination method is the one that I just did a few moments ago, where we're going to get the same coefficient in front of either the x's or the y's. So we have 1 over 2 x minus 1 over 3 y equals 5 over 12, like so. Right? And we're also going to have 5 over 6x plus 1 over 2y equals 1 over 6. So now I've got to say, well, which of these can I most easily turn into the other one, right? Or both turn into the same thing. And 1 over 3 and 1 over 2, well, how about I multiply this one by 2 over 2 and this one by 3 over 3, right? Or even just by 1 over. No, I won't mess with it. I won't start doing anything fancy like that. How about I just multiply this whole side by 3 and this whole side by 2? That's the easiest way to do it. So I'm going to go ahead and do this one here. It's going to be 3 outside of 1 over 2x minus 1 over 3y equals 3 outside of 5 over 12, like that. So this one then is going to become 3 over 2x minus y is equal to 15 over 12. Yeah, how about I just cancel that? So it's going to be equal to 5 over 4. Yeah, so it equals 5 over 4. All right. So now I'm going to go ahead and do this one over here, just down below it. Actually, no. No, I'm going to do that one down here, straight below here. right? So I'm going to do 2 outside of 5 over 6x plus 1 over 2y is equal to 2 outside of 1 over 6. So that's going to be, this is going to cancel, and this is going to become a 3. So it's going to be 5 over 3x plus y is equal to 1 over 3. Okay, so now once I go and put these two together, I'm going to move this guy over here now, and this is going to be 5 over 3x plus y is equal to 1 over 3. It's going to be over here. Then I'm going to go ahead and I'm going to add these guys together. Right? So I'm going to end up with 3 over 2 plus 5 over 3 x is equal to 5 over 4 plus 1 over 3. Like so. Right? So I'm just writing it out now as I haven't already solved it. Right? So now I'm going to, we know we need to make these so that the denominator is the same, so I'm going to make both the denominators 6. So this is going to become 9 over 6 plus 10 over 6 x is equal to, and over here I'm going to use 12 for the same thing. So this is going to be 15 over 12. Well, I had to put it back to it afterwards anyway, apparently. Plus 4 over 12. So this now is going to become 19 over 6x is equal to 19 over 12. Oh, cool. Okay. So now we're going to have x is equal to 19 over 12 times 6 over 19. Right? You see? It looked weird for a bit, but we got there. This 19 is going to cancel with this, and then 6 over 12 is the same as a half. X is equal to a half. Look at that. Isn't that pleasant? Isn't that wonderful? You go down through all that working, and it's like these numbers are just totally going off the wall, and then you're rewarded with a nice even number. Doesn't necessarily confirm that you got it right, though, unfortunately, because I've talked about metagaming for these ones before. You really can't afford to do that because sometimes, especially on a test or something like that, you really don't know if it's going to be right or wrong just from doing that. Okay, so then I'm going to go ahead and let's see. I'm going to go ahead and put that back into the equation up here. X is equal to a half. So we're going to have let's put it into the other one. I'm going to have 5 over 6 times 1 over 2 plus 1 over 2y is equal to 1 over 6, right? So then we have 5 over 12 plus a half y is equal to 1 over 6. I'm going to go ahead and move that. Yeah, I'm going to move that over here. So we're going to have a half y is equal to 2 over 12 minus 5 over 12. So a half y is equal to negative 3 over 12, which is the same as negative 1 over 4. So y is equal to 2 times negative 1 over 4. So y is equal to negative a half. Hey, excellent. So then our POI for this one is going to be 1 over 2, negative 1 over 2. Yeah, good. Droning on there a bit. And I've zoomed in a touch too much. But there we are. Math 1101C. Okay. So that was, I think, all that I needed to get to for Math 1101C. It's good. I don't think I had any other, I don't see any other questions in chat from today. It's good. Let's see. Oh. Okay. Well, yeah, I don't believe Esther's in the chat. You can correct me in the next few minutes if I'm wrong, Esther. If you're here, I'll go over trimmed mean, which I think you are going to need to know. If not, I'll wait and I'll do that another day. But this was 1101C was all I had to correct for today. So these workings, yeah, these are some very useful workings that I can now go and send off to a student that did that activity. Okay, how about I'm just gonna hang out for a minute or so, and just wait and see if anyone submits anything. If not, I'm going to take an early day today. I think I've yeah, I've been putting in quite a lot of work to try to get the internet sort of sorted out here. I'm super glad that I was able to do a stream today after all, though yeah, it took a bit of finagling, I gotta say, on my part, and it's still not really back to normal, unfortunately. Um, but hey, I was able to do it, so that's an important part. I want to you know allow people to be touching base with me every day and to give good I don't know, a good centering, a good grounding for the sort of teaching that I'm doing here, to be able to, I don't know, broadcast over Twitch, right, to anyone who wants to watch. Super grateful for the platform and for being able to spend part of my day teaching people over this sort of public TV format, right? Which I think is quite great. Anyway, thanks for hanging out today, folks. I am going to, yeah, I'm going to call it early today. I'm going to go get some other work done, and yeah, hopefully tomorrow, hopefully for tomorrow's stream, I'll have a much better setup that will um, solve some of the bandwidth problems. All right. Thanks very much for watching, and yeah, have a great day.